Hi everyone, this is the 8th video in algebra series and I'm covering section 10.10 functions part 2. So today I'm going to talk about even and odd functions. Let's start with even functions. Okay, they have two requirements. The first one is a domain. They need to have an identical domain respect to the origin. Identical domain. And the second requirement, which is a really important one, is f of x should be equal f of negative x. So let me give you a couple examples of an identical domain. So imagine this is my number line and this is point 0. For example, if we are missing a member right here, which is 1, and this is our domain, this is not identical domain because the positive numbers include all the numbers beside 1, but the negative numbers have everything. So this is not an identical domain. In order to make this an identical domain, we need to make another hole right here at -1, or in other words, r minus -1 and 1. This is an identical domain. And let me give you an example of f of x equals f of negative x. Imagine my function, which is f of x, is equal x squared. I wanted to see what is f of minus x. So instead of x, I need to put negative x, which is negative x to power of 2, which is same as x to power of 2. So f of x is equal to f of negative x. And the important thing about even functions is they are symmetrical about the y-axis. So as you see, this function, which is x squared, is symmetrical about the y-axis. Domain is identical or symmetrical, and the graph is symmetrical around y-axis. So now let's move on to the odd functions. Again, odd functions have two requirements as well. The first one is domain. I'm not going to write it again, but they should be identical as well. The second one is, which is really important as well, is f of x should be equal negative of f of minus x. So these functions are symmetrical, but not about x-axis and not about y-axis. They are symmetrical about, let me show you a great example right here. As you see, this is x-axis and this is y-axis, and this is y, or f of x equals x to power of 3. So as you see, we meet the requirement of the domain, and f of x, which is equal x to power of 3, minus f of negative x, which is negative x to power of 3, times negative, which is negative x to power of 3, times negative, which is positive x to power of 3. So this is an odd function because it meets this requirement. But let's take a look at this graph. these functions are identical or symmetrical, not about x-axis and not about y-axis. So what I can tell you that makes basically a lot of sense is draw the line of y equals negative x, and as you see, let me do that, there are symmetrical times negative 1 about y equals negative x. So that's another way to realize an odd or even function. Let me give you like a quick example. For example, we pick f of 1, which is right here, 1 and 1, it's right here, and I pick f of negative 1. F of negative 1 in this function is going to give me negative 1. So I put negative 1 and I get negative 1 right here. So what I do, I multiply negative 1 by negative 1 and it gives me positive 1. So that's how I realize this is an odd function. Again, thanks for watching our videos. I'm going to post the Google Drive accounts link on the first comment. Feel free to ask us any questions regarding your math problems on our website and also on our email at learnmatfastonline@gmail.com. Have a good one.